Welcome, my dear students. In this session, I'd like to discuss with you a very important topic, COVID 19. Is it a virus or man made nanoparticle? So, let us further explore. So, in this current scenario, when we look at this COVID 19 statistics as on 10th May 2021, the world has witnessed around 6.8 millions of new cases of COVID 19. Then, around 157.9 confirmed cases are there in the world. We have witnessed miserably 3.3 millions of deaths due to COVID 19. In spite of all these situations and pathetic conditions, we were able to administer successful vaccine doses for around 1.2 billions of people. When we look at the confirmed cases country-wise, in USA, we have got nearly about 32 millions of confirmed cases of COVID 19, followed closely by India with 22.7 million cases. Brazil is struggling with 15.1 million cases, and France with 5.7 millions of COVID 19 attack. So, in this situation, we have to learn several new things and we have to explore what are the possible solutions or remedies to come out of this critical situation. I have highlighted certain important aspects in this session. Nanoparticles, where I'll be talking about the particle nature, size, characteristics of nanomaterials. Then what are all the nanotoxic behavior and what are the correlations between these nanoparticles and COVID 19 virus. The same nanoparticles which may be toxic can also be used as a defense mechanism or defense entity in nanotherapeutics. Let us look at this one by one. Nanoparticles, when we consider this, we need to know about the nanometer. We know about 1 meter, so nano means 10 power minus 9 meter. When we look at the diameter of hydrogen, it is around 1 Angstrom. So it means I can stack 10 nanoparticles. So it means we can interpret the diameter of hydrogen atom as 10 nanometer. When we closely look at the diameter of COVID 19 virus, it is around 100 nanometer. So the particle sizes are almost matching. Now I need to talk about solute and solvent so that we can have some better idea about the nano activity. Solute, when we consider solution, let me consider sodium chloride solution. Solute is the smaller portion in the solution, whereas solvent occupies the major portion. For instance, in the case of sodium chloride salt is the solute. But when it is dissolved in the suitable solvent like water, it gets completely dissolved. And the size of you cannot see, in fact, the sodium chloride once it is completely dissolved in the water. So that is the dissolution, the perfect dissolution or solution. Similarly, in the case of dispersions, in fact, these solutions can be classified into three. One is true solution, another is suspension, where you can have clay particles, and these dispersed particles can be seen visibly with naked eyes. But in between that you have colloidal dispersions. So that will be in the range of nanometers. So since we are going to discuss about these nano-sized material, we should know some basic terms associated with this nanoparticles or nanotechnology. See, these nanoparticles, as you know, finer the particle size, greater will be the surface activity. Let me consider the catalytic activity. We say catalytic activity. Catalysis means the reaction accompanied by the catalyst. After all, a chemical reaction is the cleavage of old bond and formation of a new bond. So what is the role of catalyst? It enhances the rate of the reaction. So there are so many catalysts available nowadays. Nanoparticles, we have very advanced level of catalytic activity with nanoparticles. So industrially they are very, very significant. Now let me talk about the surface activity. I was talking about the surface activity. What is that surface activity? Surface activity means there will be some adsorbing material. So it is a equivalent term to the solvent where solute is dissolved. Because when we talk about solution, it can be a solid-solid solution, solid-liquid solution, gas-liquid solution, liquid-gas solution, etc. So likewise, based on the physical state, we can have variety of solutions. Let me consider the solid-solid solution, where these, even in gas-solid system, some of the gaseous particles can get adsorbed over the adsorbent, that is the substrate. So there is a difference between absorption and adsorption. Absorption, it is an interfacial phenomenon. For example, we can consider dyeing process, where the substrate to be colored can be completely, that is, colored with the help of absorption of dye. So it is an interfacial phenomenon. For example, a plastic can be completely colored. So when you cut the plastic component, you can see the coloring everywhere, even dyeing. So dyeing of hair, something like that. In the case of adsorption, you can find only superficial trapping. So that is the superficial phenomenon. Whereas absorption is interfacial. It penetrates into the body. So luckily, these nanoparticles have both characteristics. It can adsorb, that is spread over, diffuse over the substrate, as well they can penetrate into the substrate once they have established the contact with the substrate. Here the adsorbing surface can be called adsorbent, and adsorbate are the adsorbed particles. For instance, let me consider the virus or dust that is caught on the rough or porous surface, that is the adsorbent. So virus is the adsorbate, and the porous substrate where it is locked, it is adsorbed, is called adsorbent. I hope now it is very clear. And you should know something about solvation. Solvation means that is surrounding of solvent molecule around the solute. So before getting dissolved, these solutes are surrounded by the solvent molecules. In case of water, it is called hydration. So for any solvent, the solvation should take place, and so that the solute is completely dissolved. Similarly, here in emulsion, we call missile formation, missile or missile formation. So when you find the grease particle or a dirt particle on cloth, it cannot be easily washed away. So what we do, we add soap solution so that we are able to get the emulsion. What do you mean by soap in this case? That is the emulsifier. It is the bridging agent between the ionic and non-ionic system. Water, it is ionic, polar, whereas grease is non-polar. So these two are immiscible. For example, let me consider a test tube. In the test tube, let us take oil and water. Oil and water are immiscible, but that can be made miscible by adding a detergent or soap solution. So here, oil is non-polar, that is hydrophobic. Hydrophobic means it doesn't water. It is anemic to water. It is not compatible with water. Whereas water, as you know, it is polar. So oil and water, they are immiscible. That can be made miscible by using emulsifier. But what about the role of emulsifier? It should have both characteristics of polar and non-polar nature. In fact, that is this emulsifier will be having long tail-like hydrophobic material. With the help of this tail, it can penetrate the grease particle. And they have polar heads where it can establish contact with water. Likewise, it will form a missile, a corona-like structure, so that it can be dissolved. So a grease particle can be dispersed in water, and that can be removed. So you should let us have some knowledge about that. Now let me proceed further. What is coagulation? The coagulation is, the best example for coagulation is blood clotting. When the blood is inside the blood vessel, it is not getting dried up. In fact, I would say blood is a linear, polymer. It's a polymer only. Whereas when they have a contact with air because of the hemoglobin, and what happens here, that is, it can interact with the oxygen, and there are some proteins called fibrin that will trigger the clotting mechanism. So coagulation means the liquid becomes semi-solid, a gel-like substance. So there are two kinds of activity taking place inside our body. When there is any cut open, the blood should not be oozing out of the body. So there will be a preventive mechanism. This it will trigger the thrombocytes, the platelet plugs, and in turn that will be combining with the fibrin protein, and there will be a fibrin network, so that will prevent the oozing out of blood. So it is the superficial clotting at the injury site. So this is one kind of clotting that is useful. Whereas sometimes because of the antibodies or due to some internal mechanisms, what happens is the blood has the tendency to clotting because of coagulation. This is a very dangerous situation. And that is why when a patient is found to be positive with the COVID-19, this kind of clotting takes place. So we have to be very careful about that. So these are all the biochemical aspect of these studies. And the other speciality of nanoparticles is they have high surface area to volume. As I already told you, when you reduce the particle size, the surface activity will increase. And it will have the topographical or morphological features. And sometimes it can go uncontrollably also, and they can aggregate themselves, but by using proper techniques it can be controlled. That is, the aggregation of nanoparticles as a monolayer can be controlled also, but it is based on the substrate where it is going to have the contact. Now let me talk about the interaction of nanoparticles with the body. As I already mentioned, the size is very, very important. Because of its smaller size, actually smaller the size, the danger is more. After all, it can be easily carried away, or it can interact with the pollutants also. And that is why the nanoparticles are very dangerous. And handling of nanoparticles sometimes, when you handle the nanoparticles, it can even penetrate through the skin. Particularly nanoparticles with less than 50 nanometer are very dangerous, and they can directly interfere with the cells. So based on the size of the nanoparticles, chemical composition, even it may be inert, but because of its particle size, it will disturb the biological system. And also the surface structure. So the structures can be, nowadays we talk about nano, robo, etc. We can modify the structures of nanoparticles. So based on the absorbing nature of these nanoparticles, this may be very dangerous and interact with the body very easily. And these nanoparticles have the greatest tendency of accumulation also. They have the binding tendency with toxic pollutants, and that is why they can easily transport the pollutants to the body. They may cause pulmonary diseases. They can travel freely in blood vessels, and once it is traveling in blood vessel means it can go to any place in our body. So it can attack brain, liver, lungs, everywhere. And when we talk about this nanotoxicity, as I already mentioned, the safe handling is very, very important, because it is totally unsafe for the biological system. As I already mentioned, it will easily enter the human body, and that too at cellular level. and it can penetrate into tissues and organs. It can also be carcinogenic. Some nanoparticles are allergic, and as I already mentioned about the absorption nature of these nanoparticles, because of the particle size, they can be trapped anywhere. So when the nanoparticle, that is the adsorbed particle, and the substrate, so the bond between these two are established by means of physical contacts, that is known as physisorption. And when the absorption can be converted into a chemical bonding, that is the bonding is established. Chemical bonding is established between the adsorbed particle and adsorbent, that is adsorbate and adsorbent. That results chemisorption. So once chemisorption is established, it would be very difficult to remove the adsorbed particles from the adsorbent. Why? Because it has chemically established through the valency electrons. See, that is a physical process. Physical bonding means it is, after all, a van der Waals force of attraction among the molecules. But the chemical bond is established between the atoms in a molecule, and that is taking place through the valency electrons. So that would be very difficult to break that bond. And that can be done only by the chemical means. And it will trigger blood clotting also. These nanoparticles can trigger blood clotting. As I already mentioned, finer the particle size, greater will be the surface area. And that will enhance the catalytic activity. So that is why they enter into the human system very easily, and that is particularly through the our lungs at the cellular level. So as I already mentioned, it is airborne because it can be diffused like a gas, is it not? So the nanoparticles with less than or around a 10 nanometer size can behave like a gas. And as I already mentioned, it can penetrate through the skin also. And it is because of its SAM nature. It is called self-assembly of monolayer. So that is a special character of nanoparticle. So when the nanoparticles are adsorbed over the surface, what happens is they assemble in such a way, they try to occupy the entire area, the spreading nature. You know very well that is, being a gas, it has got greater diffusing nature, is it not? The rate of diffusion will be more. And it can diffuse three-dimensionally in the case of gas when it is available externally. But being nanoparticles adsorbed over the system, it can be spread two-dimensionally. And it can penetrate into the biological systems also. And there are some nanotubes, they are all like small threads. They can be compared with the asbestos fiber, and they can cause lung fibrosis. In fact, that is a couple of decades before, there was a disease called silicosis. In those days, that is in paint industries, we used to grind asbestos powder in dry grinding process as well as wet grinding process. In those days, these dry grinding process were banned because of diffusion of these asbestos fibers. And the fullerene, the buckyballs, they can attract even electrons. So it means these nanoparticles can be controlled remotely by wireless technology also. So it can damage the free radicals. When we compare the structure of COVID or SARS-CoV-2 virus, you can watch this, what you are able to find out here. You can find some similarity here, is it not? And you can see the self-assembling protein nanoparticles on the right side. So they almost look similar to this virus. And that is why there is an attempt to make vaccinations based on nanoparticles. And this antibiotic theories can be applied. So just by looking at the resemblances, they can be cheated also. So I'll be discussing in detail about this nanoparticle in pharmaceutical applications. Now we'll talk about the correlation between virus, COVID-19 virus and nanoparticles. As I already mentioned, the COVID virus is a surface protein. With a spike, it may cause cell entry. And its size is almost 100 nanometer, so that it can form a bonding with the substrate. And it will trigger uncontrolled induced immune system. You can find in COVID positive patients, when you check the blood, the high levels of IgG, that is immunoglobulin, and this will mislead to a chronic infection almost similar to HIV also. And it will cause inflammatory condition of the liver, that is a chronic hepatitis, and it will seriously lead to multiple sclerosis that attacks the central nervous system. And when you look at the X-ray or the the scanning, you can find the multinucleated giant cell formation inside the lungs at various locations. The fibrin that is responsible for clustering, and particularly in the pulmonary tissue, so that will form giant-like masses inside the lungs. Now let us consider the nanoparticles. They have the similar nature. Nanoparticles of less than 10 nanometer can easily enter into the cell. They can get absorbed, and particularly research studies have shown rigid multi-walled carbon nanotubes can induce the immune system, so that the antibodies are triggered against the nanoparticles of carbon materials. And it has been reported in vitro as well as in vivo. In vitro means that is it has happened in the test tubes, that is in glass, in laboratory, as well as in the animals, that is in organs of the animals, testing animals. The global cell hyperplasia and foreign body giant cell formation can also take place by this rigid multi-walled carbon nanotube, that is RMWCNT. Now we will talk about this nanotherapeutics. So when we consider the nanotherapeutic uses, we need to study the inorganic as well as organic nanoparticles and their influences in therapeutic applications. Especially gold nanoparticles are used in nanovaccines. They can boost an immune response. They can combat mutations, and they are virus resistant. When we consider the silicon nanoparticles, they are also used in vaccine as a vaccine platform in HIV. Quantum dots are detected uh, and they can be diagnosed in medical applications. Silver nanoparticles have very good antiviral properties. When we consider organic nanoparticles, these cyclodextrin NPs nanoparticles, lipid nanoparticles, then cytosine nanoparticles are very popular. These cyclodextrin nanoparticles are hydrophilic externally, but hydrophobic, that is lipophilic. Lipophilic means they are that is a friendly to lipids, that is compatible with lipids. That is basically they are non-polar at the central locations, and it will increase the solubility of drugs because of this structure. They can decrease the toxicity associated with the drugs so that the powerful drugs can be effectively administered without any or with reduced side effects. Then we have the lipid NPs. They are popularly known for their high biocompatibility. They can be integrated easily with the hydrophobic type of drugs as well as hydrophilic type of drugs. Then chitosan NPs, they can work against hepatitis C virus. When we look into this pharmaceutical nanotechnology, there are a lot of improvement in solubility of drugs so that it can be easily administered in one's body. The controlled release of drugs is also very important, and for a longer duration it can be done. And as I already mentioned, the side effects can be reduced. Then we can target specific cells also, and the drugs can be delivered in a very safe and secured manner because it is very target specific. Then it has got very good efficient absorption of proteins so that the drug molecules can be easily, that is, tuned or designed. It can be used for diagnosis also. Nanoparticles have similar size to the virus, so they can interact with the proteins and disrupt the virus replications. We can tackle COVID-19 by nanoparticles because there is an interaction between these nanoparticle and COVID-19 virus also. And there are a lot of antiviral properties of nanoparticles. As I already mentioned, they are selective, they can be targeted to the particular region. And nanoparticles can be porous, hollow, so that it can be absorbed at suitable places. Proteins adsorbed on nanoparticles can form a dynamic corona, that is, a species with multiple corona-like spikes. This can be useful for folding and unfolding, like zipping and unzipping the proteins. And particularly, it will have a greater interaction in terms of that is solvent interaction inside the body. So it's called in vivo solvent interaction. So this I should have mentioned as a Nanodefence. By wrongly I have given the title. Kindly correct that, Nanodefence. So this Nanodefence, I mean these nanoparticles can also be used for the defense mechanism. Since these nanoparticles are comparable, they have comparable size with virus, they can interact with the proteins And as I already mentioned, it can disrupt viral replications. And it has got precise targeting of cellular entry pathways. So it can easily bound to the viral genome. And we can modulate the viral transcription so that the reactive oxygen species can be, that is the production of ROS can be triggered. ROS is nothing but the intracellular chemical species containing oxygen. They are very reactive towards lipids, proteins, DNA. They are more reactive actually than oxygen. They can be superoxide anions, hydrogen peroxide, and hydroxyl radicals also. And they are responsible for triggering variety of biological events inside the body. So we can make use of these nanoparticles in a defense mechanism against any attack by the virus or external microbes, and it can activate at the mitochondrial level, and that is why these nanoparticles have very good defense mechanism. So I have cited all these references. You can go through this original literature so that it can be very useful, and you will have a greater eye opening about the nanoparticles, and whether the virus is nanoparticle, and how the nanoparticles can be effectively used as a pharmaceutical weapon against this COVID-19 virus. So thank you very much for watching this video. If you have got any research or project, you can collaborate with us, especially in nanomaterials. So I got nearly about 30 years experience in research, and probably that is my guidelines will be more useful to young guys, and I am also ready to learn a lot of things from you. Thank you very much for watching this video. Give your comments.